So in this video, I'm going to teach you how to draw structural diagrams. Here's the steps that we're going to do. First, we're going to add up all the valence electrons. We're going to count the total number of electrons to make all the atoms happy. What I mean by happy, I mean filled outer shells. Then we're going to subtract those numbers, the number that it wants minus the number that it has. And then we're going to divide that by 2. And that answer is going to tell you how many bonds to draw. And then the last step is to always fill in the rest of the valence electrons to fill all the atoms up and make their octets full. So here's an example. NH3, which is ammonia. N is the central atom, and it has 5 valence electrons. I know that because it's in group 15. And it wants 8 valence electrons. I know that because every atom on the periodic table wants 8, except for hydrogen, which wants 2. Hydrogen is in group 1, so it has 1 valence electron, but my formula is NH3. I have 3 hydrogens, so the hydrogens in this molecule really have 3. And each hydrogen wants 2, but again, I have 3 of them, so really this molecule, this hydrogen of this molecule wants 6. So then I apply the formula. How many does it want? This whole molecule wants 8 for the nitrogen, and 6 for the hydrogen. That's 14 total electrons would make this molecule happy. Now it has 5 on the nitrogen and 3 on all of the hydrogens. That's 8. So I do my math, wants minus has, 14 minus 8, and I take that number 6 and divide it by 2, and I get 3. And that means I need 3 bonds to draw my structure correctly. So I have 4 atoms that I need to attach with 3 bonds. This can be done pretty easily. So your next step is to figure out who's in the middle. Well, I said earlier, nitrogen's in the middle. Nitrogen is central because it's most metallic. Now, when we usually think of metallic character, we think of furthest to the left. Now, you might be saying, well, hydrogen is further to the left than nitrogen, and that's true, but hydrogen can never be the central atom because it can only hold 2 electrons, which means it can only form 1 bond to it. If you ever have more than 1 bond to a hydrogen, you've done something wrong. So nitrogen is more metallic than hydrogen. So we fill in nitrogen in the middle and we add all of its valence electrons. Remember, nitrogen had 5. 1, 2, 3, 4, 5. Now I have my paired electrons on the bottom, but you could have them on the top, right, or left. It doesn't matter. As long as you have 5 electrons, you're good. Then we need to draw in bonds to connect the other elements. And you always start with single bonds. And if you have to add in the multiple bonds, you can do that later. So I add in a hydrogen on this unpaired electron here. There's 1 of the hydrogens. I'll do the same thing on the top. There's 2 hydrogens. And on the right, there's 3 hydrogens. So my formula is done. I have 1 N in the middle, 3 H's attached. So that's NH3. And if I look at my octets, everybody's happy. All 8 electrons are accounted for. Nitrogen's happy, and each hydrogen wants 2, and they have 2. So we're good. So there's another way of indicating bonds. So instead of using dots, like in that last example, or the example you see here to the right, we often use lines to indicate a bond rather than a dot. So when you use lines, this is called a structural formula. When you use dots, it's called a Lewis dot diagram. In my opinion, they're both the same thing, and one is not more right than the other. If I asked you to draw a structural formula and you drew a Lewis dot diagram, I would never mark you wrong, and neither would any of the graders on the Regents exams. But when you're drawing lines, you need to remember that each line represents a single bond that contains 2 valence electrons. So 2 dots being shared between 2 atoms is 1 bond. So instead of showing it with dots like that, you can show it with lines like this. So if I'm counting electrons here, when I get to these lines, I count them as 2. 1, 2, 3, 4, 5, 6, 7, 8. 8 on that oxygen. That's how I know this oxygen is happy. Each hydrogen has a line to it which represents 2 electrons, so each hydrogen is happy. So that's the correct structure. So again, you could draw these either way, Lewis dot diagram on the left or a structural diagram on the right. It's completely up to you. So let's do another example. Hydrogen cyanide. So carbon's the central atom here because it's the most metallic. Nitrogen has 5 valence electrons again because it's in group 15, and of course it wants 8. Everybody wants 8 except hydrogen. Carbon has 4 valence electrons because it's in group 14, and it also wants 8. I just said a second ago hydrogen has 1 valence electron, but the hydrogen wants 2. So we'll do our math. The whole molecule wants 8 plus 8 plus 2, or 18 electrons, which would make this molecule happy. But it has 5 plus 4 plus 1. It has 10 valence electrons. So we do our math, wants minus has, which is 8 divided by 2. That means 4 bonds. So I have 3 atoms that I need to attach with 4 bonds, which means this is going to require multiple bonds. So let me show you how I do structural diagrams with multiple bonds. So now we're ready to draw our molecule. Before I draw, I like to remind myself how many bonds I need to draw. I need 4 bonds on this molecule here. So let's start with the central atom. There's carbon. And we're going to connect the other elements with single bonds first. So we'll attach the hydrogen on one side and the nitrogen on the other. Then we're going to add the rest of the bonds where necessary and possible. So I need to attach 2 more bonds. Now I have a choice. I could attach it to the hydrogen on the left, or I could attach them to the nitrogen on the right. And there's only one right answer here, and it's to attach to the nitrogen. I can't attach any more bonds to this hydrogen, because remember, hydrogen only has a 1s orbital. That orbital can only fit 2 electrons, and by drawing this bond here, we're showing it having 2 electrons. So if I put more bonds on it, I'm violating a rule of electron configuration that I can't do. So our only solution is to put our other 2 bonds on this side here. So there's my 3rd bond, and there's my 4th bond. Then we need to check every atom's octet and make sure it's happy. So this hydrogen wants 2, and it has 2, so we're good. This carbon wants 8, and it has 8. This nitrogen wants 8, but it only has 6. Remember, each bond is 2 electrons, so I'm only showing 6 electrons on that nitrogen. So our last step is to add unshared electrons where necessary to make this molecule and these atoms happy. So we need to add 2 unpaired electrons, or 2 paired electrons that are unshared on that nitrogen. So now it has 8 electrons. Let me show you one more thing here. Resonance is when there is more than one valid structural formula possible for your diagram. So let's consider the molecule ozone. Take a minute here and try to figure out how many bonds ozone, O3, is going to need. Remember to do your little math formula, wants minus has divided by 2. So the molecule wants 24. Each atom, each oxygen in this molecule wants 8. So 8 times 3 is 24. Each oxygen atom has 6, but again I have 3 of them. So 6 times 3 is 18. 24 minus 18 is 6. And 6 divided by 2 is 3. So I need 3 bonds to attach 3 molecules. So let's draw it. So I need to attach 3 oxygens together. I like to always start with single bonds. So there's one of my oxygens, and then there's the 3rd one. Now I've only used 2 bonds, and I need 3. So I'm going to put the double bond on this one here, and then my last step is to check the octets and fill in the extra electrons that are needed. So I'm going to need 6 on this oxygen. I'm going to need 2 on this one to have it sharing 8, and I'm going to need 4 on this one. So this is one way to draw it, but I made the decision to draw the double bond on the right. I also could have drawn the double bond on the left, like this. So which one is it? Which is the correct answer? Is it the top? Is it the bottom? Does it matter? It actually does matter. The answer is both. Both of these are correct, and oxygen exists like both of these at the same time. It's actually a hybrid of the two. So to show resonance in a structure that has resonance possible, it's kind of a pain, but you have to draw it twice. You have to draw it just like I have here, but then use a double-headed arrow between them. And this is showing that the molecule goes back and forth between both structures. That's what resonance is. This can only happen when you have a mix of single bonds and double bonds. And be on the lookout for it. I'm going to put it on one of your quizzes or tests to see who's really paying attention and remembers to draw it correctly. So let's wrap things up here. To find out how many bonds to draw when making a structural diagram, remember the little formula that I've given you. Wants minus has divided by 2. How many valence electrons the atom wants, and everybody wants 8 except for hydrogen wants 2, minus how many valence electrons the atom has. Now you can figure that out multiple ways, but I usually just go off its position on the table or its electron configuration that is in the lower left-hand corner on the periodic table. Whatever that answer is divided by 2, that will tell you how many bonds to draw. The more metallic an element is, the more likely it's going to be in the center. So always when you have 3 or more elements in a structural diagram that you're drawing, you need to first figure out who's most metallic. Then start with single bonds and add multiple bonds in later that you need based on the answer to your little math problem there. Always check your octets and make sure everybody's happy, and you need to add unshared electrons at the end to complete the octets. We're going to practice this a lot. This takes a little bit of practice to get good at, but as you do this, you're going to see the same structural diagrams popping up on Regents questions over and over and over, and you're going to likely memorize a lot of these things. But if you memorize anything, memorize that little formula I gave you, wants minus has divided by 2. It's not on the reference table, but if you can keep that in your head, you can figure out how many bonds to draw on any diagram, which is the first step into getting a correct answer.